Okay, so this is Feb March 2020 paper 1-2. Question number 1, use of the data booklet may be appropriate for some questions. Okay, so what number of protons, neutrons, and electrons are present in the ion Fe3 plus? Of course, we can see the periodic table. The proton number for iron is 26. Okay, and mass number is 54. So 3 plus means loss of 3 electrons. So it would be 26 minus 3. That would be equal to 23 electrons, and protons would remain the same. Okay, and you can find out the number of neutrons by just subtraction with, you can say, mass number minus proton number. So you would be getting the number of neutrons. So of course, for question number 1, the answer is A. Okay, it's very easy. For which hydrocarbon are the molecular and empirical formulae the same? So butane is C4H10. Of course, when you are going to divide it by 2, so you would be getting C2H5. So the molecular and empirical formula both are different. They are asking the same one. So ethane is C2H6, and after dividing by 2, it would be CH3. So molecular and empirical formula both are different. It's wrong. Then this is spent 1 ene. It's C5H10. So it would be C2H5. So molecular and empirical formula both are different. So propane is C3H8. We cannot divide this by any number because we need the common number by which I can divide carbon and hydrogen as well. So molecular and empirical formula both are the same. So that's why option D is correct. Okay. Which molecule does not have any 90-degree or 180-degree bond angle? So if you can check C2H6, C2H6 means that if you're going to draw, this would be this would be C2 and then H6. Okay. I told you when we were discussing electron pair repulsion theory, you are supposed to calculate the lone pair and the bond pair. It has 4 bond pairs and 0 lone pair. When you have 4 bond pairs and 0 lone pairs, so the shape is tetrahedral and the bond angle is 109.5 degrees. So 109.5 degree, of course, I can say that this molecule does not have any 90-degree or 180-degree. If you can check carbon dioxide, so the carbon dioxide would be this. In this, the bond angle is 180 degrees because it has 0 lone pair and 2 bond pairs. Okay. PF5. PF5. Okay. PF5. So in this, you can see 90 degrees, 180 degrees. Okay. Or you can see 90 degree. Okay. Or you can see 90 degree. So they were saying does not have any of the 90 and 180 degree. SF6 octahedral. In octahedral, there would be 90 degree and 180 degree, just like that. SF6. SF6. So this is 180 and this is 90 degree. Okay, so that's why option A is correct. Okay. The following data are needed for this reaction. Okay, for this question. On heating, sodium hydrogen carbonate decomposes as shown. Okay, decomposes as shown. What is the enthalpy change for this decomposition? Okay, so this is your equation. This is your required equation. Okay, 2NaHCO3 gives Na2CO3 and H2O and also CO2. So you can see this. Okay, NaHCO3 is going to react with HCl and is going to form sodium chloride, H2O, and then CO2, and the value is minus 38.97 kilojoules. Okay, so you would be multiplying this value by 2 because this is 2. So I'm going to multiply with the coefficient. Okay. And then this Na2CO3 is going to react with HCl again, and it's going to form this, and this, the same product. I'm not supposed to multiply this value by 2 because in this equation you can see the coefficient is 1. Okay. So this is my indirect route. I am going downward. The arrow is also going downward. You are not supposed to change the sign of this value. It would remain the same. I am going upward, but this arrow is going downward. So I'm supposed to change the sign of this. That is plus 96.59. So you would be getting C. You would be getting C. Okay. Easy. It's related to Hess's law basically. Okay. And then in the redox reaction shown, how do the oxidation states of vanadium? How do the oxidation states of vanadium and sulfur change? So I have found the oxidation number of vanadium in VO2 plus, that is plus 5. That is plus 5. And then I have calculated the oxidation number of sulfur in this, that is plus 4. And it's changing from plus 5 to plus 3. Changing from plus 5 to plus 3. So plus 5 to plus 3, plus 5 to plus 3. It may be C, it may be D. Okay, it may be C, it may be D. And then sulfur is plus 4. And in this, sulfur is plus 6. So it's changing from plus 4 to plus 6. So of course, the answer is D. Okay, the answer is D. The equation for the reaction between silver chloride and aqueous ammonia is shown. What are the units of Kc for this reaction? Of course, the formula is product upon reactant. Of course, the formula is product upon reactant. And this is your product. Okay. This is your product. And this is your reactant. We are not supposed to include the solid in this Kc expression. So that's why I'm not going to add silver chloride solid in the Kc expression. Okay. So you can see this moles per dm cube, moles per dm cube. This is ammonia. Ammonia is also moles per dm cube, but the coefficient is 2. So the power is 2. So that's why. So they are the same thing. In the numerator, it's mole per dm cube to the power 2 because mole per dm cube and then mole per dm cube. Both are mole per dm cube. And it's also mole per dm cube raised to the power 2. So they would be canceling each other and you would be getting no unit. So for this reaction, there is no unit. Okay. Then sodium azide decomposes as shown. Which volume of nitrogen measured at room temperature and pressure will be produced by the decomposition of 150 grams of sodium azide? So you can see that 150 gram, the mass is given to you. I'm going to find out the moles. So the MR of sodium azide, that is NaN3 is 65. I got the moles of NaN3, that is the moles of sodium azide. If you can see the mole ratio between sodium azide and nitrogen gas, that is 2 is to 3. Okay, I got the moles of sodium azide, that was 2.307. I need to find the moles of nitrogen gas. So after cross multiplication, I would be getting the moles of nitrogen. And then they were asking the volume in decimeter cube, volume would be equal to mole multiplied by 24. So I would be getting 83. So that's why answer is B. Okay. Then a stable ion N5 plus has been produced by research chemists. Which structure is most likely to show the electronic arrangement of this ion? देखो, you have to find out the structure in which everyone has their complete outer electron. Okay. If you can check option A, if you can check option A, 1, 2, 3, 4, 5, 6, 7. It's incomplete. It's wrong. Let's check option B. 1, 2, 3, 4, 5, 6, 7. It's incorrect. Okay. 1, 2, 3, 4, 5, 6, 7, 8. This nitrogen is happy. Let's check this one. 1, 2, 3, 4, 5, 6, 7, 8. Happy. Then again 1, 2, 3, 4, 5, 6, 7, 8. Then happy. Then again 1, 2, 3, 4, 5, 6, 7, 8. Then this is happy. Then 1, 2, 3, 4, 5, 6, 7, 8. This. So option C is correct because this is one in see the complete outer electrons. Okay. Question number 9. 1.8 grams of water heated to 227 degrees Celsius in a sealed container turns to steam with a pressure of 200 kilopascal. What is the approximate volume of the container? Okay. So you are supposed to convert the degree Celsius into the Kelvin. So I'm supposed to add 273 into this. I would be getting 500 Kelvin. You have to find out the moles of water. MR of water is 18, so 1.8 over 18 would be equal to 0.1 mole. I'm going to apply PV is equal to nRT, and I have to find out the volume. So the volume would be equal to nRT over P. N is mole, I got 0.1, R is constant, that is 8.314. Then this is temperature, 500 Kelvin, and this is the pressure. We are going to convert this pressure into Pascal. So 200 times 10 to the power 3. I'm going to multiply this by 1000 to convert from kilo to Pascal. Okay. Then you would be getting your answer. That would be B. Okay. So by using this formula, you would be getting the volume in meter cube. Remember, in meter cube. Okay. In meter cube. And then when the equation is correctly balanced, what is the value of C? What is the value of C? So you can balance it in two ways. Okay. If you want to apply the rules that I told you in redox chapter, so you can do as well. Like let's suppose first of all you have to split this equation into two parts. Okay. This into this and this into this. Like I did this. And then you have to balance the non-metal, balance the metals first. Then you have to balance non-metals. Then you have to balance oxygen by H2O. Then you have to balance hydrogen by H plus. Then you have to balance the charge by adding electrons. Okay. And then you have to add the two equations together. And then you can see in your final equation what is the coefficient of H plus, that is C. So I got 6. That's why the answer is D. That's why the answer is D. Okay. So you have to balance it. It's easy. Hmm? Okay. And question number 11. The main stage in the contact process is an equilibrium reaction. Okay. So which row describes the effect of the named condition on the equilibrium yield? So presence of catalyst. Remember, the job of the catalyst is to change the rate of reaction, not to increase the amount of product, not to increase the yield. Yield means amount of product. Okay, so there is no effect on yield. There is no effect on yield. It may be A, it may be B. Then we have to check the pressure. High pressure. How many moles of reactants you have? 3 moles. And how many moles of product you have? 2 moles. So after increasing the pressure, you would be converting the higher moles to the lesser moles. Means the reaction would go in forward direction. Okay. So when the reaction would go in forward direction, so the amount of product would be increasing. So increases yield. So of course option B is correct. You're not supposed to try this one because confirmed option B is correct. Okay. Question number 12. X and Y are oxides of different period 3 elements. Okay, period 3 elements. Okay. And if 1 mole of X is added to water, the solution formed is neutralized by exactly by exactly 1 mole of Y. What could be the identities of X and Y? Let's suppose I'm trying option A, it's P4O10. Okay. Let's suppose this is X and I'm going to react with water and it's going to produce H3PO4. The solution is formed, is neutralized by exactly 1 mole of Y. It's Al2O3. It's Al2O3. And H3PO4 is going to react with Al2O3 and then it's going to form AlPO4 and then 6 water molecules. Okay, and 6 water molecules. So ratio, you can see the ratio, you can see the ratio is 4 is to 2. Ratio is 4 is to 2. Okay, 1 mole of X is added to water. The solution is neutralized by exactly 1 mole of Y. This is not 1 mole, this is 2 mole. Option A is incorrect. Then, and remember, this is quite tricky question because you have a good grip on inorganic chemistry. You have a good grip on how to balance a chemical equation. Otherwise, you won't be able to do this question because a, the whole time you would be writing down equation and you would be balancing the equation. Okay, so you must know how to balance a chemical equation. You must know. Okay, so then let's try option B. Then let's try option B. SO3. First of all, I'm going to react it with water and it's going to form sulfuric acid. And then sulfuric acid is going to react with this Al2O3 and then it's going to form this. Again, the ratio is 3 is to 1, not 1 is to 1. I need 1 is to 1. Then P4O10 is going to react with water. It's going to form H3PO4 and then H3PO4 is reacting with sodium oxide and it's getting this. So it's 4 is to 6. Okay. And then you can do option D. SO3, SO3, that is going to react with water. Okay. SO3, that is going to react with water. So it would be forming what? H2SO4. Okay. It would be forming what? H2SO4. And then what you have to do in this question, what you have to do in this question, if it would be forming sulfuric acid, then sulfuric, is this equation balanced? Is this equation balanced? 4 oxygen, 2 hydrogen, 2 hydrogen, 1 sulfur, 1 sulfur. Yeah, it's balanced. Then H2SO4 is going to react with sodium oxide. Okay. And then it would be forming, it would be forming Na2SO4 and plus water. So since the ratio is 1 is to 1, that's why option D is correct. That's why option D is correct. Okay. Okay. Question number 13. Compound Z is insoluble in water but soluble at low pH. Okay. Low pH means in acidic pH. What could be compound Z? Barium carbonate. Um, Compound Z is insoluble in water. Okay. So means that barium carbonate is insoluble in water. Okay. And if you can see barium chloride, it's soluble. Barium hydroxide, it's soluble because I told you the solubility of hydroxide increases down the group. The solubility of hydroxide increases down the group. And then barium sulfate is also insoluble, but barium sulfate, uh, you can see BaSO4, BaSO4 is going to react with sulfuric acid or any acid. Sulfuric acid or any acid. You can see there is no reaction. There is no reaction. Okay, there is no reaction. So it's insoluble in water and also it's insoluble in acid. Huh, if you can try barium carbonate, so of course it contains carbonate. You know, the carbonates are bases. carbonates are going to produce carbon dioxide when they are going to react with an acid. So according to the statement, they were saying, but soluble at low pH. You know what does it mean? It can react with an acid. It can react with an acid, but barium sulfate is not going to react with an acid. Okay, so that's why option A is correct. Again, it's a tricky question. Hot aqueous sodium hydroxide reacts with chlorine. Which statement is correct? The oxidation numbers of chlorine and hydrogen both change in the reaction. Of chlorine and hydrogen, this is an example of disproportionation reaction. And if you're thinking how I know that this reaction is disproportionation reaction, when we were discussing group 7 halogens, so I told you chlorine is going to react with sodium hydroxide, and we did two types of reaction, with cold NaOH and with hot NaOH. Both reactions were disproportionation reaction. If you can see, it's 0 and it's -1, it's +1. Chlorine is oxidized and reduced. So only the oxidation number of chlorine is changing. They are saying in option A, chlorine and hydrogen both are changing. No, only the chlorine, like the oxidation number of chlorine is changing. Okay. Then option B says the oxidation numbers of chlorine in the products are -1 and +1. No, we have calculated that this is +5. It's not +1. Okay. And then C, if the aqueous solution sodium hydroxide is cold, the reaction produces NaClO instead of NaClO3. If you remember, if you have memorized the reaction, so then you would be able to solve this. Of course, with the cold NaOH, the product is NaClO rather than NaClO3, remembered. And then in D, sodium undergoes this, no, chlorine undergoes disproportionation. Okay, chlorine undergoes disproportionation. Okay. And then question 15 says solid ammonium chloride nitrate is put into a test tube and solution X is added to it. Of course, it contains ammonium. The resulting mixture is warmed and the gas given off is tested with damp red litmus paper. The litmus paper changes color from red to blue. B for base, B for blue. B for base, B for blue. So of course they are testing ammonia. As you know, we were ammonium. So ammonium releases ammonia. Ammonium releases ammonia. So of course, uh, you have added sodium hydroxide. Okay, of course you have added sodium hydroxide. That is the strong base. When a strong base reacts with ammonium salts, so displacement reaction takes place. How I can say that this is a displacement reaction? Because sodium hydroxide is a strong base and ammonia is a weak base, so it can displace. Strong base can displace the weak base. That's why ammonia is released. Okay, that's why ammonia is released. Okay, so identity of X is 100% sodium hydroxide, and the role of X okay, X is sodium hydroxide. So sodium hydroxide is a base. So what is the definition of base? It's a proton acceptor. That's why option P is correct. Okay. Question 16. Sodium, magnesium, and aluminum are three elements in period 3 of the periodic table. Each element forms an oxide. Which row is correct? So sodium oxide, it's a metal oxide, basic oxide. It's a metal oxide, okay? So are three elements in period of the each element forms an oxide. Which row is correct? So sodium oxide is basic, of course. Okay. Because this is a metal oxide, then they are saying magnesium oxide. Magnesium oxide, you can say amphoteric. No, no, it's also a basic oxide. So option A is incorrect. Okay. If you can try option B, sodium oxide is giant ionic. Okay, okay. It's an ionic compound. So let's say it has a giant ionic structure. So it's also a giant ionic structure. But what about aluminium oxide? It is also a giant structure. They are saying simple molecular. Option B is incorrect. Then if you can try option C, they are saying sodium oxide is going to have high melting point. Yes, because it's an ionic compound. Magnesium oxide is also an ionic compound. It would be having high melting point. And aluminium oxide is also an ionic compound. But why they are saying it has a low melting point? So that's why option D is correct. Because sodium oxide, it readily reacts with water. Since it's a group 1 oxide, group 1 metals are more reactive and slight reaction with water, magnesium oxide, reactivity decreases across the period, and aluminium oxide is not going to react with water, due to its layered structure. The layers are formed, okay, on the surface of that oxide. That's why. Hmm, Okay, so option D is correct. And a student investigates calcium nitrate crystals by heating them in the apparatus shown. A colorless gas leaves the apparatus at Y. At Y, at Y, at Y. A flame is held to this gas. They are testing the gas. They are testing the gas. What is being released? What is being released? So they are saying which observation would the student make? Litmus solution changes to blue. What was the reactant? Of course, we have calcium nitrate. It releases the two types of gases, NO2 gas and O2 gas. Okay, so NO2 is an acidic gas. It's a non-metal oxide. It's an acidic gas. Okay, and but they are saying in the question, colorless gas leaves the apparatus at Y. A flame is held to this gas. So litmus solution. This is a litmus solution. Litmus solution. What is in this litmus solution? Acidic gas, NO2 gas. Okay. So when acid is there, so what would be the color of that litmus? You can say blue to red. You can say blue to red. So of course, changes to red. So it may be C, it may be D. It may be C, it may be D. And then you have to see flame at Y. Flame at Y, since this is the test for oxygen. So whenever you have an oxygen near to the flame, so you would see that the flame burns more brightly because oxygen helps combustion. Whenever there is a plenty of oxygen, so you will see that the flame would be burning in a brighter manner. Okay, simple. That's why option C is correct. क्वेश्चन नंबर 18 कहता है कि हाउ डज concentrated sulfuric acid behave when it reacts with sodium chloride? When it reacts with sodium chloride. So sulfuric acid, okay, and sodium chloride. Chloride, Cl minus, is a weak reducing agent. Okay, is a weak reducing agent. It cannot reduce the sulfuric acid. It's only acting as an acid. I told you sulfuric acid has dual behavior. When you have concentrated sulfuric acid, so it can behave as an acid and also the oxidizing agent. But the thing is that Cl minus is not enough reducing agent, so they can react. Like you can say, I can say that this reaction is a redox reaction. It's not a redox reaction, okay? When there would be an iodide, so that I can say that this is a redox reaction. But right now, this is a simple acid reaction. So, H2SO4 is behaving like an acid. Simple. Okay. Because oxidation number is not changed, of course. If you can find out the oxidation number of sulfur in H2SO4, so you would see that the oxidation number of sulfur would be +6. And if you can see sodium sulfate, again the oxidation number is +6. It's not going to change, so I can't say that this is a redox reaction. And of course, if there is not a redox reaction, so how can I say that this is an oxidizing agent? Simply, that's why I'm saying it's as an acid only. Okay, simple. And question 19, which is statement about nitrogen or its compounds is correct? In the Haber process, the temperature is kept high to give a good equilibrium yield of ammonia. The temperature is kept high. No, it was an exothermic reaction. It was an exothermic reaction. So if you're going to Increase the temperature of an exothermic system, so the reaction would move backward. So the yield of ammonia would be decreasing. So option A is incorrect. Okay. Option B says nitrogen gas is unreactive because of the strong nitrogen-nitrogen double bond. Nitrogen has a triple bond. They are saying double bond. It's incorrect. Option C says nitrogen monoxide will react with carbon monoxide under suitable conditions. Basically, if you remember, this is the reaction which occurs in a catalytic converter. Okay, where in the presence of platinum and palladium and rhodium metal, the nitrogen monoxide is going to react with carbon monoxide, and they are going to form nitrogen gas and carbon dioxide. Okay, and then if you can see option D, the formula of ammonium sulfate is NH4SO4. No, 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 no. It's just like that. This is the formula for ammonium sulfate. Okay, this is the formula for ammonium sulfate. That's why option C is correct. Okay, simple. Then question number 20. Which pair of compounds are functional group isomers of each other? Okay. Uh, Functional group isomer means that the molecular formula is same, but the whole functional group is different. But the whole functional group is different. Uh, Butane one all is this, okay, and butanol is this. If you can count the number of carbons and hydrogen, if the molecular formula is the same, then you can say they are isomers of each other. But if the molecular formula would not be the same, so you cannot say that these are functional group isomers of each other. Okay, so it has C4 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4H10O. And if you can count this 1, 2, 3, 4, 5, 6, 7, 8. C4H8O. No, option A is incorrect because molecular formula is not the same. Functional groups are different, but molecular formula should be the same. Okay, so let's try option B. Ethyl propanoate. It's an ester and pentanoic acid. And pentanoic acid. So you can see that this is a pentanoic acid and this is ethyl pentapropanoate. So if you can see 1, 2, 3, 4, 5 carbons we have. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10 we have and O2, C5H10O2. If you can count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So C5H10O2. So since the molecular formula is the same and functional group is different, so I can say that they are isomers of, they are functional group isomers of each other. Okay, you can try C and D, but of course they are not correct, but you can try this. Okay. um 21. Which raw identifies a suitable starting material and reagent that can be used to produce butane nitrile? You know butane nitrile? Hmm? Butane nitrile means that it would be CH3, CH2, CH2, and Cl. It's called butane nitrile. Okay, it's called butane nitrile. Four carbon atoms. Four carbon atoms. Okay, so uh, it's going to have three carbon atoms. It's going to have three carbon atoms. Okay, it can produce butane nitrile because bromine would be substituted by CN. But the thing is that HCN cannot displace bromine. Okay, HCN cannot displace bromine since HCN is a weak acid, so it partially dissociates. Okay, it would not be giving you enough amount of cyanide ion or nitrile ion that can displace this bromine. That's why you can opt option B, in which you can see that sodium cyanide would be substituting this bromine, because sodium cyanide is going to completely dissociate into Na plus and Cn minus. So when you have enough amount of cyanide ion or nitrile ion, so you would see that the bromine would be substituted by Cn, and as a result you will see that butane nitrile would be formed. Why not? I am opting option C and D because already it has four carbon atoms, and it when it would be substituting bromine by this nitrile, there would be five carbon atoms. That would be called pentane nitrile. But I need butane nitrile. But I need butane nitrile. Okay. So that's why option B is correct. Okay. C, question number 22. See question number 22. So in this question, the diagram shows the structure of ethane dioic acid. Ethane dioic acid. Ethane dioic acid reacts with ethanol in the presence of a few drops of concentrated sulfuric acid to form a diester. The molecular formula of the diester is C6H10O4. What is the structural formula of the diester? First of all, you have to react this dicarboxylic acid with ethanol, because they were they were mentioning that like diester would be forming. So of course you have to react ethanol twice. First, ethanol would be reacting with this side of carboxylic acid, another one would be reacting with this carboxylic acid. So they would be forming a diester just like that. Just like that. This is the diester. Okay, this is the diester. So after forming the diester, you can match your structural formula with the given structural formula. Okay, so it's going to match with option B. It's going to match with option B. You can try by yourself as well. It's a good question because you must have a good grip on how to write down the structural formula. How to write down the structural formula, okay? Hmm. Okay, then question number 23 says the infrared spectrum shown was obtained from a compound J. Which statement about J is correct? Of course, always remember whenever you would see the peak at 1600, so you can say that this is the peak for the carbonyl. Especially this is for the carbonyl, okay? Which statement about J? Both carbonyl and cyanide are present. We have to see the peak. Where is the peak for the cyanide? Remember, the peak for the cyanide ion is present at 2200 centimeter inverse, but I cannot see any peak at 200 centimeter inverse. There is no peak. So there is no cyanide. There is no. In option B, they are saying neither cyanide, neither carbonyl. No, we have carbonyl. We can see the peak at 1600. In option C, carbonyl is present, but not cyanide. Yeah, C is correct. C is correct. So basically it all depends upon what you are looking at. Like you have to see the data booklet and you have to see the values, and then you can decide which functional group is present in the following compound. Okay, it's an important. अच्छा फिर आते हैं हम question 24. A section of a polymer chain is shown. What is the correct monomer? What is the? It's quite tricky question, you know. It's quite tricky question. So you can see that uh, this is a polymer. Okay, this is a polymer, right? So I have drawn the structure. This is a double bond. You know that always the polymer is formed. Always the polymer is formed when you have a double bond in your monomer. If you don't have double bond, so there would be no any polymer possible. Okay. So I have drawn monomer. Okay. So you can see this. This is CH3. This is hydrogen. This is hydrogen. Okay. And this is branch. And this is another branch. This is another branch. Okay. So the red one is the branch carbon. Okay. And the black one is the part of long chain. So you can see this is your correct option. This is the monomer. This is the monomer. Like it's hydrogen, CH3. I'm going to match it, okay? This is for this, and this part, the whole part is for this. So option A is correct. Option A is correct. It's quite tricky option. You have to see by yourself after drawing a structure, after drawing the structure by yourself. By yourself, okay? Again, your structural formula should be very good. Should be very good. Otherwise, like you will be confused in this question. Okay, 24. Then we have 25. Structural isomerism and stereoisomerism should be considered when answering this question. How many non-cyclic isomers have the molecular formula C5H10? Non-cyclic isomers, non-cyclic isomers. Remember, have the molecular formula C5H10. You know what does it mean non-cyclic? A straight chain or a branch chain. You're not supposed to draw in this manner. It's a cyclic structure. It's a cyclic structure. So C5H10 is your alkene, it's pentene. This is the first one. I have changed the position of the double bond. Okay, they were saying you have to consider stereoisomerism in this structure. The cis trans were not possible because it's containing the same atom. But in this structure, cis trans isomer is possible. It's different, it's different, it's different, it's different. Yes. So 2 and 3. Okay. So 1, 2 isomers. So total 4. So total, yeah, total 4. And then you can see I'm going to write down the branches in this manner. Okay, I'm going to write down the branches in this manner. So you will see that the total isomers, non-cyclic isomers, have the molecular formula. They would be 6. So 1, 2, like then you have to draw cis and trans. You have to draw cis and trans. Okay, then this one, then you can draw this one, and then you can draw this one. The best way to do this question is to give the name to all the compounds. So the name should be different. If the name is different, so the isomer is different. If the name is the same, so isomer is not possible. You know what is the name of this compound? It's 2-methyl. 2-methyl bute 2-ene. It's 2-methyl bute 1-ene. Okay, it's 2 comma 2 dimethyl prop 1-ene. Name is different है ना? देखो इसका different था, इसका different था, इसका different है. And what is this? तो इसको पहले आप cis trans बना लेना. cis trans बना लेना. ओके, फिर इसको नाम दे देना. ऑफ कोर्स ये डिफरेंट है, ऑफ कोर्स डिफरेंट है. इट्स पेंट वन इन. So all are different. So all are isomers of each other. Simple. Simple.